Hello and welcome to the webinar Scripting in PTV Vissim using the COM interface. COM scripts enable users to go beyond the general functionality of PTV Vissim. In this webinar, I will explain how COM scripts may be applied in the traffic simulation software. I will explain what COM is, what is used for, and how you can use it. In specific, I will explain the Vissim COM object structure and how to make use of the COM help to find the specific command for the desired function or the desired attribute you want to access. I will also demonstrate how you can make use of internal scripts in Vissim. As time is short in this webinar, I'll only explain the very basics. We offer a one-day training course for COM where we can teach you more, where we can help you to write your code and can provide more tips how to write your code. Note, the webinar will be recorded and will be available shortly after the webinar. So if you need to see some part of the webinar again, watch the video. I am Jochen Lohmiller, Product Manager for PTV Vissim at PTV headquarters in Karlsruhe, Germany. Before I start, here's some technical information about the webinar. Attendees are not able to use their microphone, but you are free to post comments and questions via the questions window. My colleague, Lukas Koch, who is also Product Manager for PTV Vissim, will reply during the webinar. After the webinar, we both will be available for some time to answer your questions via the questions window. So I'll give a small introduction about what is COM. COM stands for Component Object Model. It's a technical platform by Microsoft to provide inter-process communication and dynamic object creation within Windows operation system. So what does it mean? It means simple that you can access from one program, from one application to another one, meaning, for example, from Excel controlling Vissim or for your programming environment accessing Vissim. Which programming languages can you use? With COM, you can use any programming language, whatever you like, whatever you prefer, also which integrated development environment, IDE, you're using. However, for internal scripts in Vissim, you need to use Visual Basic scripts, Python scripts, or JavaScript. In this webinar, I will demonstrate the COM interface by using Python. So why COM? Why do you need it? What is possible with COM? Short answer would be almost anything can be done with COM, and I'll show a little bit, and we have an example you can watch them. There are almost no limits. So if there's any functionality missing in Vissim for your project, what you need, you can use a COM script to add this functionality. So how to use COM? In order to control Vissim from via COM from external program, it needs to be registered as COM server. This is normally done automatically or by default from your installation. However, you can trigger it manually over the help menu of Vissim, register COM server, and if you click on that, it'll automatically register as COM server. I'll close now Vissim and demonstrate how it works with Python. So here we have a small script which I will start now for running, and you see it's running now. What it does, first I have to say to Python that it should get the library of COM, and with this library I open a Vissim instance. So it does, now you see it in the background, it opens Vissim. Then it loads a specific network, load net, and then it starts a simulation. So I control Vissim from external, from this Python environment, and what you saw is it opens Vissim, it loads the network, and currently still running the simulation, which will finish with very soon. So once a connection to COM is established, you can make use of the entire Vissim COM library. The Vissim COM library is structured like this. So there's the Vissim, the iVissim is the highest rank object of the model. iVissim allows access to the sub-objects iNet, it's the network, and iSimulation, there everything regarding the simulation is stored in there, and further lower rank objects. For the object iNet, access is possible to the sub-object iLinks, iVehicle inputs, areas, so for pedestrians, and also like dynamic elements could be here. There could be the iVehicles as well. And then it goes further down from iLinks. There's a sub-object iLanes, and also some function for this iLinks. For example, accessing the attributes via the function addValue, or creating new links or removing links, which is also possible. So you can create and remove network objects using the COM interface. So you see there's the leading I of some of these values, and here on the function we don't have the leading I. The leading I and leads, it's an interface, and you need it especially when you need to declare variables, which you don't have to take care of in Python, but in other programming languages. So you can find this structure is documented in the so-called COM help in Vissim. You can access the COM help using here the help menu, COM help, and it opens this help. So there's a small summary, a reference to the some basic examples, and then there are all the classes listed. You have it all also here at the objects, and what you see here for each of the objects, there is a single element, there's a collection, and there's a container. This is for all of the elements, and I'll explain you the difference of these three types in the next slide. So first, the container. The container contains a amount of different single objects. So in case of links, we'll have several links, and these in the container are the real objects. So for example, go to Python. Here, if I access Vissim net links, I'll get here the container, and in here I have all my links in the network. So I'm accessing now here, I established a connection from Python to this Vissim instance, so I'm accessing this network. And I can show you here in the COM help, if we go to links, iLink container, I have specific methods for the iLink container, and they are different between the container, the collection, and the single object. So what I can do with the container, I can add a link or remove a link, and I'll demonstrate that. So Vissim, I go back to the links and I add a link. And now if I want to know about this function, I can click on it, and it says, make it a little bit smaller here. It says a second input. Get rid of this. I need the key, so this is the number here. What you have here in Vissim number, you can keep it 0. Then Vissim will give a new key, but I'll give a specific key, 42. And then you need a line string with giving coordinates. This can be in 2-dimensional or 3-dimensional. We'll make a link from here to here. So this is coordinates 0, 30 to coordinate 200, 200. And then as a third input, we need the lane width. So let's make a 2-lane link with 3.5 meters width. So if I press enter now, you will see pop up link, creating a new link. So I enter it, and you see here the link appearing from coordinate 0, 30 to 0, 30 to 200, 200. So this can be done by the iLink container. And also, if we go back to the iLink container, I can access attributes. So for example, links, get multi-at values, and then I write down an attribute name, for example, the name of the link, and I'll get feedback of all link names which are existent here in Vissim. So this is this column here. So these are the container, and the container, these are the real objects. The second type is the single object. So if I have one link only, and with one link only I can do different things compared to when I have a group of links, or the container contains always all existing links. So if we go to the iLink, the single object, I can do like recalculate a spline, and I can access to the indirect attributes. For example, the lanes. I cannot access for all links to the lanes. That is not possible. So I have to go with a single link. So accessing a single link is mainly done from the container by using the function item by key. With item by key, I access a specific number of the link. So for example, we choose link number 1. So it gets me a link, an iLink object, and this is item by key number 1. And here I have access to the add value interface, and can also read the name or length 2D, for example, which is 212, and you see it here in Vissim 0.714, 0.714. So I get information about a single link. I can also set attributes. This is also possible with the container. So length of 2D is not changeable, but for example, I change the name to Heid und Neustraße, which is a street of our head office here in Karlsruhe. And you see now here, activating this, it changed to Heid und Neustraße. And to prove that it wasn't before, here we call the link name, it was link number 1 before the name. So this is single objects, and you have different methods which are listed here in the COM help for single objects. And then there's the collection, and the collection can be a different amount of vehicles. It doesn't has to be all the links. Sorry, not vehicles, links, like in the container. Here we only have a separate number and not the real object. We only have pointers, references to the objects. So for example, and this is why it's important, if we have a specific route, a vehicle route, there we have a link sequence. Let's say link number 1, link connector 10,000, link number 2, and so on and so on. And if I would adjust, or if I adjust this route, I will drop some links and I will add some other links, and this will not make the link disappearing, deleting from my network. Just the references to these links get lost in the collection. And that's why there's a collection, and the collection is very similar to the container, but if you remove a link from a collection, it will not disappear in your network. If you remove a link from the container, it will disappear from the network, and it will also then not be anymore in the collection. So that's the main difference. So to access the collection, we have here iLink collection. Here I have several methods as well, I can also access attributes, but here I don't have the item by key because it's not all the links are inside. So I'll just copy this one. I want to access the root. This is a longer term. So here from Vissim net, and I access a vehicle root decision static number 1. Show it here. This is vehicle routing decision static number 1. And I access here the vehicle root static. So this is one level further down, and also number 1. So this is root number 1, and I'll access now this object using this command. So this is my root number 1, and this root 1, this has a specific link sequence. And you see here the link sequence. This is now an iLink collection. And I have several methods. For example, I can use the count command, and it says it's 9 links in there in this section. We can check that. Let's make numbers. So it's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 9 links. And I also can get the attributes. For example, get multi add values, and I want the names, and I get the names of this collection of this root here. And it's also possible to change the values. So let's make set all add values, and then for example on the link attributes we can change link behavior type, and let's see here, all the links, they currently have link behavior tab 1, and if we change it to 3, enter, you see directly some of the links, and we can sort them. These links were now switched to a link behavior 3. So it's possible in both in the container and in the collection to make changes to the attributes. Note you always can go from the container to a single object, also from the collection to a single object. This is possible, and then use the functionality what you have on a single object. So continuing explaining these com help, here on iLink single object, I can access the relation, explained that before. So this is basically what you have in Vissim, which are the indirect attributes here. So for example, yeah, you can get the vehicle collection, or let's do the vehicle inputs. So if we are Vissim net links, and I need to have a single object, so item by key 1, link number 1, and here I want to have the vehicle inputs. It gives me a iVehicle inputs collection, and I can read get multi add values, for example volume 1, and it feedbacks me 800 vehicles, and we will check that. So vehicle input of all vehicle inputs on link 1, this is just this one, has a volume of 800 vehicles per hour. Here in COM, it's a continuous number for the different time intervals. So time interval 1 is 1, the second time interval is 2, and so on. This to be said. So and then these are the relations here. So you can access collections which are depending on the link, and then there's also, it's possible to access all the attributes, And the attributes which is used in COM is the by default the header which you have on the list. If your settings, if you use as main language English, and here in the list settings you use the short name, and the English short name is used for the COM interface. So for example, on links, let's make it here a little bit. Yeah, make this one smaller again. So if we want to access, for example, has overtaking lane, so we simply enter net links item by key one add value, and then type just what you see here in the header of the link, has overtaking lane, and it's 0. It doesn't have a overtaking lane. Or if we want to change the link evaluation, I just type what I see here in the header. So you don't have to check all the time in the COM help what is the attribute's name. Let's make it 55, enter, and you see changed from 10 to 55 here in Vissim. So this is quite helpful if you use COM, just checking the headers on the list. So what else is there in the COM help? There's also the reference by pages for single objects, collections, and container. The reference by pages show basically the parent object, or in other words, the answer to the question, how can I access this object starting with the main object Vissim. So for an example, I've showed that before here. So if you are at iLane, if you want to access iLanes, you need to know the parent object of iLanes is iLinks, and from iLinks I have to go to iNet, and from iNet I have to go to iVissim. And this is documented in the reference by pages. So for example, made one example. So if you question yourself, so we have here a public transport line stop, and now we want to change the departure offset of your public transport line stop. So how can I get there with COM? And this is a question what we often get in tech support. I'll explain you how. So making this one small again, using Python. So as you know, the header of the list, they are used in COM. So we search for departure offset, and it finds here on the public transport line stop attributes. So we click on that. So here is departure offset. Also here's a description about what is the value type, if it's edible, yes or no, how can I read it during simulation or write it during simulation, and so on and so on. So, but what I want now is to see how to go to find these attributes. So I click on public transport line stop container reference by, and here at the container it says it's referenced by the public transport line. So I click on that. Then I click how the public transport lane is referenced, and it's referenced by the iNet, and the iNet I already know, I'm familiar to. So Vissim net, and then I use public transport lanes, and from here I need the item by key because I only want public transport lane 1. So and then I go on, going back here. Next one is the lane stops, item by key. Again, I don't know, we want to change for all of them. So the line stops, this is now a container here containing all the line stops. So, and we want to change them. So we'll enter set multi add values. and the attribute, we know it's the name here, what we see in the list, offset, and we'll make it for item number 1. So public transport stop number 1, we'll make it 30 seconds, and for public transport stop number 2, we'll make it 90 seconds. So you see now it's 0, 0. If we activate it, it changed to 30, 90. So basically, this is how you use it. You want to access a specific attribute. So you search for this attribute, you find it, and then you use the reference by pages for finding the way from the Vissim, the parent object, to the object. Again, this reference by pages also exist for the container. For the container, this is the main object. There's only one parent object because this is where the real objects are into. From the collection, reference by, there for links, there are multiple reference by. So for each different routing, for different routes, so it could be partial, parking, or static routes. And for the single objects, they're on link. I mean, I think it's the most referenced by objects what we have. So for example, priority rule has one link only referenced. A vehicle input has only one link referenced. So this is again the differentiation between the single object, the collection, and the container here, which you already learned. Before going on here, there's one more thing to tell about result attributes. Result attributes exist for different simulation runs, time intervals, and vehicle class. What we see here is the travel time measurement. So there are different values for the travel time measurements for, say, simulation. We only want to keep with one. So for simulation run 1, there's a value. For simulation run 2, there's a value. For simulation run 3, there's a value. Also for the different time intervals, there are values, and could also be a third one for different vehicle classes, there could be values. But there's only one attribute, travel time. So how it's been done in accessing them in the COM interface. So if we search for travel time, you'll find here the iVehicle travel time measurement. Here it is, and here it says again the value type, if it's edible, and so on. And here it has 3 sub attributes: simulation run, time interval, and vehicle class. And here you can enter the number. So as an example, I copy also this code prepared. So here we go to Vissim, net, vehicle travel time measurements, and then item by key 1, so travel time measurement 1, and then accessing add value, and here sub attribute 1 is a simulation run, so we want simulation run 1, time interval 1, and then all vehicle class. So it should return the 97 if we access it, and we'll get the exact value. In case we want the result from simulation run 3 and time interval 2 and only for vehicle class 20, we'll get this value, which is simulation run 3, second time interval, and vehicle class 20. So we have this one. So this is how you use sub attributes. What you also can do, you can also get the current simulation run. You can get aggregated values. If you enter, for example, instead of the number of the simulation run, average or standard deviation, min or max. You can also do that very similar in the time interval. Instead of giving a number, you can ask for the current time interval if you run during a simulation. You can also call the last completed. and you can also get aggregated values of all time intervals of one simulation. Here you also get the total, it's the sum of the time interval, and as explained before, sub-attribute 3, you have to enter the vehicle class or the all vehicle class. So again, short example. So instead of this, we can make an average of the minimum of all, and it gives no value because somehow there's not defined value, and max we also don't get, so somehow not sure why I don't get any number right now, but this is how it works. Normally it should give the number like you can do it here in Vissim when activating here these aggregation levels, and you'll get these numbers as a feedback. It doesn't give me any error, but it won't. Now it displays. I don't know why it didn't display before. So average of the first time interval of all simulation runs, or I show you that it also works what I typed in before, the average of all of the minimum from the time intervals for all vehicle class, and we get this as feedback. So this is what it has said about the documentation, how you can find the single objects, what you want to access, how you can find the attributes, how you can find function. So it's all documented here in this COM help, and I hope you now know how to work with it. So what I want to demonstrate now is to make use of internal scripts. I'll get my I get here my Python script back in. So we are making a new here empty network editor, and if we want to use internal script, we don't have to make sure about this COM connection because Vissim does it for you, and also you don't have to access a specific Vissim instance because it's already there. You start out from Vissim, so the Vissim variable is already provided. So we only need this code to do what we did before. So we'll make a new file, and we just need, no, we don't need this. I'm sorry, we need to start the simulation. So we just need this, load the file, and start the simulation. That's it. So we save the module. I copy the path here, and I save it as module1.python. It's already existing. I override it. So, and I can now go into Vissim and use the script menu and run a script file. And I paste it here, and I choose the module 1, so it's the same path. So it will load a network file and start the simulation. I open it, and there's no new Vissim opening. It just loads the network and will start another simulation. So I use quick mode to finish that. So it's getting more interesting on application, and there's much more functionality when using internal scripts which does something during the simulation. So we make a small example about a speed limit camera. So we want to detect vehicles that go too fast. We save their speed, we take a picture of them, and then we can give the vehicles tickets, and hopefully they pay for the tickets. So we create two links. I copy and paste it here and make a connector between the two links. So Okay, connector 20 meters of the connector, and we make a vehicle input on that link with a volume of 300. So I already go into 3D mode because we set the position of our camera. So let's make it here. Okay. And we save this network as speed camera. So, and now we go into COM, and because time is short, I'll just show you the code. So when we use event-based script here, we can define event-based scripts. We can define about the scripts, how they will work. I'll show you that. So I add a script, and here I can select run type. This could be manually, so I go there, I save the script, also the reference to the script, and I can run it whenever I want it manually. And I can also do before the simulation start, after simulation, and if you want to do some post-processing, or also during the simulation at the time step start or end. So we'll have one initialization of this script before the simulation start. So we reference to this script. So this is in the same folder and the screenshot file. And the scope, and this is why we did this initialization, it defines a global variable count. I'll explain you later why we need it, but this variable will be active throughout the entire simulation if we select here the scope of the script and we change it to simulation run. And then you see this one is active now, the function name, so we have to define the function, and the function is the init function, short for initialization. So we duplicate this script, and we make also use of the main function, but not at before simulation start. We make it at time step end, and at time step end from simulation second 0 to max, and then we check for every 20th time step, because we check not in every time step if there's a vehicle too fast. We only it's enough to do it in any 20th time step. I'll explain you how, why, because what we do here in the code, so first we call or we access the global variable count, and we access here the vehicles. Here, demonstrate that in the COM code. So on iLink, there is the property vehicles. So returns the collection of objects referenced by vehicles. So this is then the iVehicle collection. So we get all vehicles. They are on link number 42. So we define this one as link 42, the selected one. This is our, go back to links. So here, this is the 20 meter where we check if the vehicles are too fast or not. So we get all of them. And then, because this is a collection, there could be several vehicles on the link. So for each vehicle which is inside this collection of vehicles, then I come down, a vehicle is only a single object, and I make use of the reading the attribute speed. So I get the speed, and if the speed is higher than 53, then it should count. So I get a count how many tickets did I get, and this is also important for if I use a file name, so I can have the next number, and this count value is active throughout the entire simulation. That's why scope is simulation run. So Vissim keeps the value of your attributes, even though Vissim calls this function very often. And then it makes a file name, speed valuation, count, and we save the speed of the vehicle in the file name, and Vissim then does a screenshot saving it as this file. And the screenshots, they are saved in the working directory. Put it here. So, and then we start the simulation. We see vehicles. It's not saved the file. Now we got our first vehicle and the second vehicle with a speed of 55, 57. This was also too fast. We can check here also this speed is now 54, so should be detected by our script, and we got this recorded. So we get the vehicles which are too fast as a camera, and we also get the speeds here in the file name. So it's a simple application. It's a short code, and here you can define your scripts without Vissim, and it runs within your simulation. It doesn't call always outside over some COM function. It just gets your script inside the simulation and executes it whenever you want. You only also can execute it only once. So as you can see, you can access all network objects with COM, so you can do almost everything with COM. If it's signal control, public transport operation, also pedestrian, if you're using VisWalk, you have the full functionality of the COM interface, so you can control your pedestrian simulation, changing graphics, routes, demand, performing results, using COM only for running simulation and varying some parameter. This is all possible with COM. So summary, what you learned today, I hope you get an idea about the Vissim COM object, how it is structured, and how you find a way to access a certain network object from the COM interface using the COM help. And also what you learned is the difference between a container, a collection, and a single object. Container, these are the real objects. The collection is only a reference, a pointer to an object, and here the single object. And for all these three different types, there are different methods and things to do. So I highly recommend reading the COM intro document. We have a PDF file which you'll find in your Vissim installation in the subfolder doc English or ing, and then Vissim 8 COM intro. So this gives also some additional introduction. Then you know the COM help, make use of it, and I highly recommend if you now start working with COM, look at our examples which you can find. I'll show you. So help, examples, open training directory. So it opens the training directory, and there we have a subfolder COM where are different examples listed in. Also there are some PDFs explaining, and if you go into one example, there's also a description, PDF, so you can read what is the scope of the simulation, how it is modeled, and so on. So you get additional information, and especially the basic commands. This is how it shows. I showed now how to use it with Python. If you want to use MATLAB, you can check this code, and here the syntax is a little bit different, how to establish the COM connection. And we have these examples, how to access add values. We have these examples for several different programming languages, C++, VBA, C#, and so on. So make use of them, of the example, have a look on it, how it is in code, and also get an idea what is possible. So also, we're at the end of our webinar. I also want to highlight on the upcoming PTV Vissim webinars. As you found this webinar, you probably have seen also that we have another webinar on February 17th about user-defined attributes and formulas in Vissim. And the next day, February 18th, there will be a webinar about scenario management in Vissim, and also many more webinars about our projects here at PTV. Also want to highlight on more PTV Vissim videos. Webinars we already held can be accessed via the webinar archive. You can find it. Also, this webinar will be uploaded to our archive if you want to watch it again. And we have a YouTube channel where you can get additional videos. It's more about project and demonstration videos. So thank you very much for your attendance. Really, I suggest reading the COM intro document and then play with the example files. There would be many more to say, but I can't do that within 1 hour. As mentioned before, we have a one-day training for introduction to the COM interface where you learn how to code and we help you how to learn the code. So thank you very much for your interest in microsimulation and joining the webinar. Should you have any more questions, you can still ask them using the questions window. Lucas and I will stay online for a few more minutes and write back to you. For all of those leaving right now, all the best to you and have fun scripting with COM for PTV Vissim.